so gorgeous. Let me work up here for a while until I get up the nerve to erase it. Alright. Tell me when we're on.
We're on.
We're on day 5 notes, and Brandon, were you here yesterday?
Yes.
Okay, so you have those. And they look like this. That's day 4. Day 5 look like this for those in TV land, video land. I'm going to put it where they can see better. Some of mine had totals on there, but that's okay. All right, the first thing you'll see that we need to learn today is a tree diagram, but that's not the first thing we're going to do. Look on day 4 notes. Could you go back and tell me what is the topic on day 4? I could be guiding you to the wrong topic.
Do you want those two-way tables and probability and diagrams?
Okay, well,
Do you want those?
all right, we did both of those things. So day 5, all right, we're going to do conditional probability. So we are on day 5. So I was a little discombobulated there, but day 5 it is. So would you draw a two-way chart, since those you love so well? I want you to draw a two-way chart. And on the two-way chart, this time, I'm going to give you all the numbers. Ready?
How big should we make it?
It can
As big as your
be-
heart desires.
Like how much else
On the
information
page.
are we gonna write on this page?
Um,
Because there's not very much space.
We don't need much, it doesn't matter, we don't have a lot of notes, I don't know. We have male, female, yes, no. The yes, no is pierced ears. So along the top, pierced ears, yes or no, and along the bottom is, along the side is male, female. Here are the numbers that go with these categories. 19, 84, 71, 4. Would you go ahead and get the totals for me? The marginal numbers. As soon as you got those, would you share them with me? What are your marginal totals here? So we have the pierced ears, yes or no, male and female. Not too many female no's, is it? Okay, are we on? We're
Yeah.
on? All right. Hello to you, Allie. Didn't
It's-
say a greeting. What?
I was gonna say it's been on, yeah.
I didn't forgot to greet you, so this is a mid-video greeting. Hope you're feeling better.
I love you.
All right, so you got some totals? Lena, what totals do you come up with?
Wait, look. I'm I'm soon. almost finished.
Okay.
But feel better. Look, Pierre loves you. And happy. Star joy. Don't be sad.
All right, Allie, what we're doing is coming up with the marginal totals on this two-way chart. Brandon, do you have some?
Yes.
What do you have here?
Oh, from well, I have 75 no's.
What about here?
I'm gonna get that right now.
Okay.
I have, oh, wait.
Okay,
I have-
Julia,
Up on that side it's 90.
thank you.
Then it's 88.
Uh-huh,
Then the bottom one, starting on the left, is 103.
okay.
Then it's 75.
And then what
And
do you
then the
have?
final is 178.
Do they add up both ways?
Yes.
Okay, so you always can check yourself if you have the right numbers, if the vertical and the horizontal add up to the total, 178 in this case. All right, so check yours against mine. Today we're going to learn about conditional probability. So let's first of all take a note. Conditional probability. May I dictate? Allie, I'm going to dictate, so have your pen ready. Conditional probability is the probability of an event given another event has occurred. Conditional, C-O-N-D-I, conditional, T-I-O-N-A-L. Conditional.
Additional probability, what's
is the probability of an event given another event has occurred. Anyone need it repeated? All right. For example, this is where we can learn. What is the probability of a male, and this is a new symbol for you. It's actually, I usually slant mine. I think the book makes it straight up and down. And that means given. So given pierced. So we read that. What's the probability of a male given the person is pierced? So let's see if we can count that out through the chart. What's the probability of a male given is pierced? This is like the two-way charts we used to do. Remember, I used to guide you to the second part of the problem where they gave you some information. So the second part is pierced. So that means I am staying in yes pierced land. So I'm actually going to circle that because I am only going to work this problem for people who are pierced. So I always go to the given pierced. And then the probability of being a male in this column is what? 19 out of 103. See how I got those numbers? You can prove it to me by trying this one. What's the opposite? What's the probability of being pierced given you're a male? So this time, see if you can do the same thing. Let me see what you got. Don't say it out loud. Bingo. Anyone else? Probability of being pierced, a probability of having a pierced ear given you're a male. I was wondering if it's the same.
This is more than I thought it would
Very good.
be. Yeah, it is a higher percentage.
Nice one.
Really?
Are they equal?
Yeah. I don't know that many. It's like
You got an answer?
Yeah,
Probability of being pierced given that you are a male. So you're going to
Just
stay
like
in
most
this
people have
column,
theirs
this
pierced.
row, because you're a male.
and
So it's going to be pierced is
yes
this over that. That's
one.
the, oh. So you can just leave it like that,
No.
Brandon?
Instead of up and down.
Elena?
Less than that, 10%.
Success?
Less than 10% of the guys, that's what I know.
Instead of
Very
in
good.
the pierced
That's
column,
right.
you're in the male
And I know
column.
a
All right, so
Oh, but
we're given it's a
lot,
male,
guys.
so I'm going to stay in male land, and this is right here. And the probability in male land of being pierced is this number over that one. Are they the same? Is 19 over 103 about the same as 19 over 90? You might have to switch it to a decimal, but I don't think it is.
21% and 18.4%.
All right, they are different. Not vastly, but they are different. So we can't, order matters. You can't assume that these two are equal. There are cases where they will be equal. Let's do the check your understanding there. See what you can get from that. Well, number one, we have to find the probability of L. I guess we have to read the problem. Brandon, would you read check your understanding where it says students?
I don't have it here, okay? I can go get it. I'll get it.
Oh, you don't have it?
Yes,
All right. Let's see if this is an extra. Oh, yes. Here's an
I
extra.
do have it.
You can have
It's in
that.
my book, thank you.
All right, so read students at the university.
Students at the University of New Harmony received 10,000 course grades last semester. The two-way table below breaks down these grades by which school of the university taught the course. The schools are liberal arts, engineering, and physical sciences, and health and human services. Read the
Keep reading.
So, this table is based closely on grade distributions at an actual university, simplified a bit for clarity. College grades tend to be lower in engineering and physical sciences, EPS, than in liberal arts and social sciences, which include health and human services. Consider the two events.
Okay, here's what I've been looking for. All that glad to this point. Consider the two events. E. What's E, Brandon?
E is the grade that comes from EPS courses.
Right, so the probability of E means it's coming from an EPS, an engineering physical science course. And what's L, Brandon?
L is a grade lower than a B.
I thought it might have meant liberal arts, but you see it didn't. It meant low grade, lower than a B. All right, so if you would, think the number 1 through. What's the probability of being the event L? So that is a lower than a B grade. So go ahead and see what you come up with there.